Right now, as you watch this, Earth may be sharing its neighborhood with a second moon, an object that can hang around for months, sometimes even years, and then vanish into the darkness like it was never there. What if I told you this moon might be only 10 to 100 meters wide, smaller than a football stadium, yet it can still become one of the most valuable scientific targets near our planet? Stay with me here, because by the end of this video, you'll know exactly how Earth can have a mysterious second moon without breaking physics. It sounds impossible because we grew up with one moon, one big, obvious companion. Clean story. But the solar system isn't clean. Earth can temporarily capture tiny asteroids, mini-moons, and Earth can also share its orbit with objects that don't truly orbit Earth, yet still move with us in a bizarre gravitational dance that looks moon-like from our perspective. Here's what makes it so mind-bending. These objects can loop around Earth in the sky and then escape. Some trace horseshoe paths, like they're drawing a giant cosmic racetrack around our orbit. Others appear to hover near us, drifting forward and back, as if they're tethered to Earth by an invisible rope. And the wildest part? A few can look like they're orbiting Earth even though they're technically orbiting the Sun. So what are we really seeing? Are these moons real moons, or optical illusions created by gravity and perspective? And if we can't easily spot them until they're close, how many have we already missed? Because on this question, scientists aren't even confident we've found most of what's out there. Let's ground this in the normal science first, because this is where things get strange. Earth's gravity dominates a region of space called the Hill sphere, the zone where Earth can hold on to satellites against the sun's pull. Our moon lives comfortably inside it, orbiting at about 384,400 kilometers away. If a random asteroid passes by Earth, what should happen? Most of the time, it should just fly past. Capturing something into orbit usually requires a big energy loss, like atmospheric drag, a collision, or a perfect gravitational setup, because the sun is powerful and Earth is moving fast. But the real solar system is a multiplayer game. Add the sun, Earth, the moon, and a passing asteroid, and sometimes you get a temporary capture. The asteroid enters Earth's neighborhood. Its path bends just right, and for a short time it becomes bound, looping around Earth before it escapes again. That's a mini-moon, a temporary natural satellite. Then there's another category that fuels the second moon headlines, co-orbitals. These objects orbit the sun in about 1 year, just like Earth, but their geometry makes them appear to hover, loop, or oscillate relative to us. Some trace horseshoe patterns, some drift around gravitational balance zones. They can feel like a second moon even, when they aren't truly captured by Earth. So the expectation is simple. Stable moons are rare. Temporary moons are possible but fleeting, and co-orbitals can mimic moon-like behavior. But the reality is messier and more exciting, because we're finding candidates that behave so oddly, they force astronomers to ask a dangerous question. Is Earth's neighborhood more crowded than we thought? Quick one, if you like space mysteries that turn into real science, subscribe. Because what I'm about to reveal is a three-part twist. Earth's second moon can mean 3 different things, and one of them could be the easiest near-Earth object humans ever try to visit, or even mine, when the timing is right. Now let's follow the clues like detectives. Co-orbitals were predicted long before we could easily spot them. When mathematicians wrestled with the three-body problem, they realized you can have stable-ish configurations where an object shares a planet's orbit without crashing into it, simply by threading the gravitational needle. Then, as our telescopes and sky surveys got better, we started finding real examples. Objects that loop relative to Earth in strange patterns, and can stick near us for long stretches of time. They aren't captured like our moon, but in the sky they can behave like a shadow companion. Then the mini-moon idea got real. With improved surveys, scientists argued Earth should temporarily capture small near-Earth objects more often than we notice, because these objects are tiny, faint, and move fast. And that's where the tension spikes. If mini-moons are common, we should see them, but we usually don't, which means either they're rarer than models suggest, or our detection systems miss most of them. Scientists around the world are basically playing cosmic hide-and-seek with rocks the size of buildings. And there's a cliffhanger that makes this even harder. When a small, faint object shows up near Earth, it doesn't come with a label. A second moon candidate might be a natural asteroid, or it might be human-made space junk, an old rocket stage or dead satellite reflecting sunlight in unpredictable ways. Confusing them is easier than you think. Here's the astounding truth, and it's the part most headlines skip. Earth's mysterious second moon is usually one of three things. Number one, a mini-moon, a temporary natural satellite. A small asteroid wanders into Earth's hill sphere and, through a delicate gravitational handshake involving the Sun and Earth's motion, becomes bound for a while. Picture tossing a marble into a moving bowl. Sometimes it circles a few times before it hops out. That's what a mini-moon does. It's not permanent. It's a guest. Number two, a co-orbital, a companion of Earth's orbit around the Sun. It's not truly orbiting Earth, but from our perspective it can look like it's dancing around us. Imagine two runners on a track. They're both doing laps, but one speeds up and slows down slightly. From the stands, it looks like one runner loops ahead, falls behind, and keeps returning. That's a co-orbital relationship. Not a moon in the classic sense, but still a real celestial companion. Number three, a misidentification, space junk, or a tricky early orbit solution. When astronomers first detect an object, they might only have a short arc of observations. With limited data, multiple orbits can fit. Add weird rotation, changing brightness and reflections, and you can mistake a hollow metal rocket body for a natural rock. Early certainty can flip into total reversal once more observations come in. That explanation is satisfying because it turns second moon from a magical claim into real orbital dynamics you can understand. But it also raises a bigger, more personal question. If temporary moons and co-orbitals are real, why should you care? Because a mini-moon is close, sometimes shockingly close. That means it can become a natural lab sample of near-Earth material. It can become a test case for planetary defense. If we can spot, track, and predict the motion of tiny, fast movers near Earth, we get better at tracking the bigger ones that could actually threaten us. And it can become a stepping stone for exploration. Depending on timing and trajectory, reaching a small captured object can sometimes require surprisingly low energy compared to other destinations. In other words, if a mini-moon shows up at the right moment, it could be an easy mode target for a mission that practices close-up navigation, sampling, and low-gravity operations. But just when you think you understand it, here comes the second twist. The most exciting second moon candidates can also be the easiest to misread. A tiny object near Earth can be a natural asteroid with a rocky signature, or a hollow metallic rocket stage that flares in brightness when it tumbles. It can look Earth-bound until more data reveals its solar orbiting, and even when it is natural, stability is tricky. Some co-orbitals can stick around in their dance for a long time. Others are temporary visitors, and their motion can be chaotic, sensitive to small gravitational nudges. One close pass by Earth, or even a close interaction with the moon, can rewrite the whole choreography. So we're left with a delicious uncertainty. Are we looking at a hidden population of natural companions that come and go around Earth all the time? Or are we hitting the limits of how well we track faint objects near our planet, especially in a sky that also contains growing amounts of human-made debris? And now, I genuinely want to know what you think. When you hear Earth's second moon, what should that mean? Should it be A, a true temporary captured mini-moon, B, a co-orbital companion around the Sun, or C, the headline should be banned unless it's a stable orbit for years? Drop A, B, or C and tell me your rule. I'm reading the comments, because this matters for humanity in three big ways. First, planetary defense. The better we get at spotting faint, fast movers near Earth, the better we get at early warning for real hazards. Second, exploration and resources. A temporary natural satellite could be the most reachable natural object we ever get as a target, giving us a chance to test missions in low gravity and learn how to work with small bodies. Third, pure science. These objects are time capsules. Their composition can tell us where they came from, whether they're typical near-Earth asteroids, fragments from the main belt, or in rare scenarios, even debris kicked off another body long ago. And here's where it gets crazy. The same tools we build to find second moons also improve tracking of everything else around Earth, asteroids and debris, making near-Earth space safer and more predictable. The optimistic part is we're entering an era of constant sky monitoring. Better surveys, faster follow-up, smarter orbit fitting, meaning fewer mysteries stay mysteries for long. The more we watch, the more these ghost moons become predictable visitors instead of spooky surprises. But this isn't the only hidden companion story. Next up, we're diving into the weird objects that park near Lagrange points, Trojan asteroids that share planets' orbits, and the growing battle to track space debris before it becomes a crisis. Thanks for watching. The universe doesn't need new magic, just better measurements to reveal what was already there.